So hello guys, we're gonna do another problem from Webwork. And let's find this integral for trapezoidal rule, midpoint rule, and Simpson rule. Okay. So I have here we have here our formula from the formulas page, and so I have the trapezoidal rule and I have the Simpson rule. So I copy here in my previous problem I was solving here. So this is the trapezoidal, right? So we notice we need to know what is n, we need to know what is delta x, and then that pretty much we just need to plug in values. So let's do this integral. So well, let me remind you again the formula. It's probably easier if I do. So remember, trapezoidal rule is t sub n, and then you got delta x divided by 2, and then you go f of x0, then plus 2 f of x1, then plus and 2f of xn minus 1 plus f of xn. Okay. So we saw that our problem, in our problem, n is 4 because you need 4 subintervals. And the interval is 0, 1. So it's something this is useful for, to focus and don't get lost on your thinking. This is 0. This is 1. N is 4. So you need to divide in 1, 2, 3, 4. So your delta x is b minus a over 4, and b is 1, a is 0, and this is 4. So basically you have 1/4 or 0.25, whatever you prefer. So let's say 1/4. So this is 0, 1/4, 2/4, 3/4, and then 1. Okay, so that's pretty much all that we need. So our formula is gonna look, so trapezoidal 4 for this is gonna be delta x is 1/4, and then times 2 is 1/8. Then I do f of 0 plus 2 f of 1/4 plus 2 f of, oh sorry, it's 2/4, not 3/4. 2/4 f of 2/4 plus 2 f of 3/4, then plus f of 1. So we have 1, 2, 3, 4, 5 numbers corresponding to 4 intervals, okay, 4 rectangles. Okay, and I mean, we don't need to make the graph of the function, although this function is famous. This function is kind of Gaussian. So this function goes something like this. Oh, sorry. This function is very famous in statistics. So this function goes like this. Okay. So in statistics, it's extraordinarily useful. Okay, so let's go and type our solution. So I need to go 1/8, and the f of 0, 2 f of 1/4, F2, F of 2 fourths, and so on. So let me type it. Hopefully we don't make a mistake. Or I don't make a mistake. So first, I'm gonna do 1/8. And then I need to do f of 0. So my function is this guy, e to the minus 2x squared. So f of 0, e to the 0 is just 1. Right? Plus, then I need to go 2 times, and then here I need to plug in my formula. And then probably I'm gonna do e to the, oh, this is annoying formula. So I'm gonna have to put probably minus 2. And do it this way so you guys learn to also type it in your Webwork. Oh, probably you guys already know, but then minus 2x squared, right? So x squared. So let's put this x in this little parenthesis. So like that. So the first one, I need to plug in 1/4 over here. So 1/4, right? So this is 2 f of 1/4, as I put it over here. 2 f of 1/4. So now I need to put 2 f of 2/4. So I'm gonna copy this guy. Plus 2 f of 2/4. Then I copy, and then the next one is 2 of 3/4. And then the last one is again a f of 1, right? So that will be over here. So let's see how it goes. So what is wrong? Oh, that one doesn't have 2. Sorry, because it's the last one. So no, it's correct. Okay. So yes. So this is the first one, and the last one is just the function, and then in the other is 2 times f of 1/4 plus 2 times f of 2/4 plus 2 times f of 3/4 and 1. My function, remember, my function is e to the minus 2x squared. Okay. So now we do. Let's do Simpson rule. Midpoint is gonna take me another formula. Let's do Simpson's, because I can copy paste here. So Simpsons, as we already did in the other examples, my formula changes, right? So Simpson's rule is slightly different, but it's very similar. This is Simpson's. So Simpson says is delta x that we already say is 1/4, and then 3 on the bottom. Yeah, sorry, delta, yeah, 3 on the bottom. And then it will be f of 0 plus 4 of f 1/4 plus 2 of f of 2/4 plus 4 of 3/4, and then f of 1. Okay, so for Simpson, I'll obtain the following. Will be Simpson will be 1/4 times 3. Now what we do is f of 0 and then we go, sorry, 4 we do 4 plus 4 of f of 1 4 plus 2 f of 2 fourths, then plus 4 f of 3 fourths, then plus f of 1. This is a formula. You want to see where is this formula coming from? You can see the book, but we understand the left and right hand side. This is just another approximation, and it turns out to be a better approximation, but we're not gonna learn why it's better. But if you take a numerical methods class, you will see why is this better. So we had 4 times 3, right? So 4 times 3. Yeah, 3. Because in the formula is delta x, that is 1 4, and Simpson's rule always had the third on the bottom over here. So let me show you again the formula over here. See, Simpson's rule always have delta x divided by 3. So that's how you do it. And then you go 4, 2, then this one is 4, and then you're done. Okay, so that's correct, right? This is correct. So again, is the difference between Simpsons. Well, there are a couple of differences between Simpsons and trapezoidal. So in Simpsons you divide by 3, trapezoidal you divide by 2, and here in trapezoidal everything has 2 in the middle. In Simpsons you alternate 4, 2, 4. Okay? This, and you know, all this is coming from linear approximation from calculus 1. Remember how do you used to find the slope of a line? Oh yeah, the tangent line, the equation of the tangent line. All this is coming from there. Okay, so let's do the last one. That is this is the midpoint rule. So in this one, you take the midpoint of each interval. So in this one, you have really you have n intervals, and then you'll have only 1, 2, you'll have exactly n values. Okay, so you plug in the middle point of the interval. Okay, so let me show you here. Now let's type the formula for midpoint. So for midpoint, so the formula is mn delta x, and then you go f of x1 plus f of x2. So, and those are the middle point of the intervals. I will show you in a second. That's f x3 plus f x4. Okay. So in this case, so what is my midpoint? So between 0 and 1 4, my midpoint is 1, 8, right? So my midpoints are 1, 8. So 1, 8, 2, 8, 3, 8, 4, 8, 5, 8, and 6, 8, 7, 8. So my midpoints are the, let me make it bigger. Sorry, my pen is not very good. So this is 2/4. So we have here, this guy is, the middle point is 1, 8. So this guy is 2, 8s. This guy is 3, 8s. This is 4, 8s. So this guy is 5, 8s. This is 6, 8s. So this is 7, 8s. Okay. And then what it's gonna do is that, as the formula shows here, the mean point rule. Oh, I didn't put the graph. Well, I can make the graph for this. So the interval, how this tells you how high the rectangle goes, right? So it goes here and then goes here. So this is the next one. It goes here. These are the rectangles. So the middle one, the middle point tells you how tall you are. So 1, 8, 3, 8, 5, 8, 7, 8. So my formula is gonna look, like this. It's gonna look like N4. So this is 1/4, and then F of the middle point, the first middle point that we said is 1, 8, plus F of the second middle point that we said is 3, 8. Then the other middle point is 5, 8. And finally, let me see, the last one is 7, 8. Okay, so I just need to evaluate in 1, 8, 3, 8, 5, 8, and 7, 8, and multiply times 1/4. So I can use what I have done before in Webwork to save some time and avoid some typos. So I'm gonna copy paste here. So the first one is gonna be, we said 1/4, right? So we just need 1/4. And you can introduce the way you want it. You can do this first in your calculator and then plug it in Webwork. I just do it like this because this will be useful for Wolfram Alpha or Maple or Mathematica when you're introducing. So my first one I said is 1, 8. So, and I don't need the 4 and I don't have the 1. So the first one is supposed to be 1, 8. The next one, so it doesn't have 2's or anything, is I said 3, 8. So no 4's or anything like that. This is 5, 8. And the last one is 7, 8. So 1, 8, 3, 8, 5, 8, 7, 8. Yeah, good. So that's how you solve it. And the other problems now are similar. So this problem is very similar. This is you just do this. This is left and right hand side. So for this one, you need to use this formula, left and right hand side. Okay? So that's the formula. And so this one should be fine. And this also, this one probably was a little bit more difficult. And this one, students were emailing me, like 3 or 4 students emailed me about this problem, so that's why I solved it. And the last one should be easier to do. This is left, right, and middle point. Okay. So please work in your homework. You still have some time for this homework, but please don't get behind. So see you soon.